Let's examine another example. The strategies for this example are universally applicable and are not limited to global outbreaks only. The above picture is a good overview of the virus propagation methods. The first vector is the security hole we've mentioned. The next method includes spreading using removable media. We'll focus on this in a minute. Local area network is the third vector. The creators of the virus attempted to save the malicious code in all badly protected network shares. The fourth technique used user password cracking to propagate the virus. The first vector was quite smart. It involved a degree of social engineering, a manipulation method we've discussed before. The windows above are well known and don't raise suspicions. We've gotten used to them being displayed as soon as a USB drive is plugged into the computer. But there's a piece of information in these windows that is duplicated. Conficker has modified the auto-run file. You can see on the left-hand side a typical auto-run file. The right side shows a file that's been altered by Conficker. The virus referred to a system library to display the window shown before. The language version and operating system version always match. Selecting the first default option did not cause the USB directories to open. What it did was launch the virus file hid on the USB stick. A portion of the virus code can be seen on the picture above. After it was launched, the virus created a new system service with a random name. System services are unique in that they run automatically even when the user who has launched them has logged out. As a result, after restarting the computer, the virus was already running in the system. The virus propagated also in another way, through passwords. The virus code stored in most common passwords. Conficker used the list to determine the password of a targeted user. It tried to submit passwords like root, test, or password, but also check the name of the authenticated user. Using this value, it submitted a potentially matching password. For the username John, it tried passwords like John123 or 1John. This resulted in massive user account lockouts. A single copy of the virus was able to block as many as 1,000 accounts. This is a hint that can help us gauge the scope of the infection. It would be enough to determine which computers are responsible for locking user accounts. If we locate them, we'll know which computers have been infected. A free optional tool for Windows administrators is a package called Account Lockout and Management Tools. EventCombMT is a component of this package. The MT abbreviation in the application's name indicates that it's a multi-threaded edition of the tool. EventCombMT enables users to read security logs from multiple computer and aggressive security logs from many computers from your network. When all this data is put into a single repository, you can run Log Parser, a tool we've shown before, to identify the IP addresses of hosts that came up in the user account lockout event record. Below you can see a Log Parser query that returned IP addresses of these computers. Performing these actions results in documenting the territory of the attack. At the same time, you should take measures to reduce the risk of infecting other computers. The first thing to do is block TCP port 445. This port is used in Microsoft Windows networks to access remote network shares. The second step is to modify access privileges to the registry key according to the strategies outlined in a knowledge base article. It's necessary to do this in a way that prevents the virus from launching in a pseudo-randomly named web service. Thirdly, you need to block the automatic launch of AutoRun. The file is stored in removable disks. By doing this, we close all the known doors that would have let the virus in. Now it's time to remove the virus from the infected computers. To do this, use specialist dedicated tools, Microsoft software, or third-person software. You can also try to remove the virus manually. We can analyze and remove viruses using sysinternals tools. We'll talk about doing this in one of the next modules. The last step is making sure that the results of the attack are removed from the system. The easiest case requires restarting infected computers. After a restart, check whether the unwanted service appears again. The case study we've presented aimed to show you how an administrator should properly react under unknown and stressful circumstances. These circumstances are a situation where an anomaly has been detected in the behavior of a system, especially if this is a security-related event. We've prepared a plan of action and need to stick to it step by step. First, identify attack territory. Secondly, document the attack and take measures to keep the infection from spreading onto other computers. This doesn't always mean shutting down the computer or unplugging the power cord. Understanding vectors of infection in the detected attack is vital. Next, we need to eliminate the consequences of the attack and make sure that all traces of the attack are completely removed from the system. Thank you for your attention.